Who am I? I'm Chris. I used to work at the Tidal Music streaming AS here in Norway. And I used to work as a test automation engineer. And I was responsible for UI end-to-end testing on pretty much every platform, from desktop to mobile devices. And during this talk, I will hopefully be able to teach you and convince you to maybe start UI automation on your own projects by demonstrating that the barrier to entry is very low. So you don't need to necessarily be a very proficient programmer. You just need to have an understanding of programming to get started. So just before we get into it, I'd like to explain a little bit about the generic QA process. In broad strokes, there are 4 stages of testing a generic product. And they need to pass through these stages before making its way to production. As a foundation, we have unit tests, which, if people are not familiar, it's just a small piece of code that tests a single piece of functionality. And then we have integration tests, which is a piece of code that tests many pieces of functionality together. And then finally, we have UI tests, which usually are at the top level. They're basically testing end-to-end using real backend and so forth. And not necessarily, you can mock the backend. But at any rate, it's supposed to represent a human being interacting with the application. So it tests all systems working together. So often there's a QA pyramid, which at the top you have, I was supposed to have this pyramid here, but apparently it's not here. But anyway, you can think of automation as a pyramid. So at the top you have unit tests. So you need, you can think of it as an inverted pyramid. So at the top you have unit tests. So you want a lot of it because they are cheap, they are fast, and they are relatively easy to make, but they are small in scope. So you need a lot of them to cover the entire breadth of your application. And as you go down the hierarchy, you can see that it gets broader in scope, but also more complex and slower to run because it interacts with more systems at once. So here you can see that at the bottom is, or I guess at the top of the bottom of the pyramid, the inverted pyramid, you see that UI tests is kind of small, and so you don't need a lot of them because one test will necessarily test a lot of different functionality interacting together. So why should you bother? I'm sure most agree that testing in one form or another is necessary, but what specifically makes UI testing so attractive, and is it worth investing the effort to get started? There's many forms of top-level testing. One might have a manual QA department, or you might have crowd testing services, such as Applause, or you might have outsourced the testing to India, where they work for almost nothing. Or so if you do have all of these systems, or maybe just one, why would you bother having UI testing at all, or UI automation? Because they're all doing the same thing, right? But I'm not here to argue that automation is to completely eliminate manual testing. The idea is that UI automation is complementary to old-fashioned organic lifeform-based testing. And how is it complementary? It frees up manual resources to be focused on where they are needed the most. So where are manual resources needed, and what are they freed from? They are freed from tasks which are boring, repetitive, and always increasing in number. So that means routine testing of core functionality. So basically when your project grows in complexity and grows in size, there's more and more features that can potentially break when you introduce new features. So if you have only manual testing, that means that every time you make a new change, ideally all the old tests that you have done and all the old functionality needs to be tested again to make sure that it hasn't broken since you introduced a new feature. So you don't just have to test the new feature, you have to test everything else to make sure that didn't break. And that is very routine, that is very boring, and it is soul-crushing work for any manual QA department person. And, but this is, since it's routine and repetitive, it is a perfect target for UI automation. And especially since often if there's many things that you need to test, then, and it has been done many times, then the steps are written down. So you know how to reproduce old bugs. You know how to reproduce any corner case that you might have had before. So when manual resources are freed from the shackles of repetitive work, they can focus on what's really exciting, and that's working on testing new features. Because new features often require suggestions for refinement, or sometimes they need interpretation for what is or isn't a bug, and there's no clearly defined steps for how to interact with this feature. That's really where you need to focus QA manual resources, because a computer can't really have the same insight necessary to provide reasonable feedback. So, the final reason for automation: a computer works for free. It's fast, it never gets tired, and can work 24/7. It is thought that 40% of all people will lose their jobs due to improvements in AI and automation. And who doesn't want to be a part of the future where the AI overlord takes over the world? So, but you might say, we don't need this because our developers do testing, which is great. But it's unreasonable for developers to test everything they are not working on, like making sure that new features don't break old features. And also, if you are just an outside person looking in on the development team, it's not like you can't contribute, because you approach the thing from a different mindset. So while you're a developer working on a new feature, you are trying to make it work. You know exactly subconsciously what might break it, or what to avoid, or how to interact with the feature. And so when you're approaching as another person on the outside, you have a different mindset, and you can try to break it. And this is also a very important perspective in many cases. And UI testing is supposed to be supplementary to unit testing. So it's not like it's a replacing thing, because did it die? Okay. Did the projector die? Var det projektoren som døde? Nei. Den skal være på. Der, ja. Oh. Hey. Yes. Now, of course, developers are it's great that developers can pick up UI testing too. Since developers are best equipped for writing automated tests, they know how to interact with the application, they know what features need to be tested, and they also have insight into what sort of corner case scenarios could arise. So, what tools do you need for starting UI testing? You need a generic test framework like JUnit or TestNG. and then you need an automation framework for the platform of your choice. So the ones I used are Selenium for web, and I used XC UI test for iOS, and I used Espresso for testing the Android application. And if you wanted to start doing the same thing, you should start looking into these tools, since these are the most widely used and the most widely known. But if you've never heard of any of this stuff, and you're not a super experienced developer, maybe you're feeling a little bit like this. I'm here trying to sell you the idea that you personally can start test automation wherever you're working, even though you have no background in test automation and you have no insight into the actual code base of the thing that you're wanting to test. If you remember the QA process for the generic product, unit tests and integration tests are usually made by developers. But UI tests can, in principle, be made by anyone who knows programming language. You don't necessarily need insight or hands-on experience with the code base. All you need is the basic ability to program, and you can start yourself. And here's what you need to start. I would advise you to start experimenting with Selenium. And what is Selenium? It is an open source library written in Java, and it's used to automate the UI testing of web pages. So basically, it lets you write automatic scripts for web browsers. You can go there, you can click that, and drag and drop and do whatever you want. And then you can replicate any sort of manual interaction with the application. So the way this works is that it uses a tool called WebDriver, which is written by Sauce Labs. It is open source, and there's a different version for interacting with any browser. The most important one is Chrome driver, which is made by Google, which allows you to basically remotely control a Chrome browser. And since Chrome is based on, since Electron is based on Chrome, that means you can use it to automate a wide variety of many different applications. So, for example, Slack is an Electron application, which I'm sure you've heard of. So, in principle, you could use Selenium to automate interactions with Slack. And every year, Google has automation summits, which they always update Chrome driver, and they always have these summits. So they take this very seriously. So it's clear that the support for using this tool is very strong. And but the same thing cannot be said for Mozilla, because the original Selenium 2, version 2, had support for Firefox natively. But now Mozilla wants to officially support automation, so they have made their own web driver called Gecko driver. And it's great to have support for this, but they disabled the old functionality, the old hack. And the new thing that they made doesn't work. So, well, you can start with Chrome, and that gives you a lot of coverage just right there. There's another advantage, and that's that Selenium is easy, but it isn't perfect. It's been around for a long time, so there's lots of documentations and solutions to common problems on Stack Overflow. And the way you interact with it is very easy. You just say driver.click or driver.go here. Right? Click on that element. It's very, very simple to understand. But as I say, it isn't perfect. And in many ways, it was made for a different time when JavaScript couldn't do many magical things that we are doing today, and running all these crazy applications where elements don't really kind of exist until you hover your mouse over something. So, so you have to figure out how to make workarounds and how to compensate for these edge cases. And that's really the part where you need to be creative and need to really have an understanding of how to make elegant solutions that don't take a lot of time, don't take up a lot of resources. But beyond making workarounds like that, it's really easy. So you should really just dive into it. It supports many languages, so it's easy to get into. It supports the apparently most popular language ever, which is JavaScript. And it obviously also has, it's written in Java, so it has support for Java. And Java is what I used to automate the desktop application and the web application. There's also support for C#, for Ruby, for Python, and the list goes on and on. And it's very simple. This is all you need to get started. This is all you need to do to start automating in principle. That's like 11 lines of actually meaningful code. And here's, so in this example, you can see that it creates a new driver. In this case, it's Firefox. It goes to Google. It finds an element, which is named Q, which is the search field, like query. And then it sends some text into that text field, like cheese. And then it clicks submit, and then it searches. And that's it. It will automatically open up Chrome and do all these things for you. So, and that's all you need to start automating on one computer. It's really that simple. So, but what can happen is, of course, things can go wrong. And tests can fail. And what will you do then? Well, you'll need a test report. And the test reports kind of look horrible, but we'll get to that later. But this is what you can do, because since you can run tests automatically on one computer, you can also run them on many computers. And there is also something you can just download on Selenium's webpage, where you can just make anything run remotely and control from a central hub. And that's called Selenium Grid. And you can run like many instances on one machine. And the lab I ran that we set up, it looked like this, where you just have a lot of computers on a shelf that are remotely controlled by one central build agent, which just distributes tests across many computers. And then people will walk by and say, whoa, these computers are working on their own. It's pretty amazing. And this could be you. It's very simple to get started. Well, it's time to talk about reporting, which is not so great if you're just using JUnit, because a report kind of looks like that. And what does that mean? It just gives you an error. And you don't know what went wrong. So you have to go and like manually debug through the test, and you have to figure out exactly at which step it failed. And there's no logging here. There's no screenshot. There's no video. So especially if you're a QA person who's just getting started on this and not a developer, and these exceptions don't make a whole lot of sense, maybe you're feeling a little bit like that. And you probably should be, because this is not the sort of reporting framework that you should be using. There's many options out there. And in particular, we used one made by a bunch of Russian hackers called Allure, which looks like that. And here you can see all the errors that appeared, and you can click on each one, and they will show you all the steps it went through, and it can show you whatever logging. It will attach any screenshot, video, or whatever file you want. And this is all free, open source, ready to go. You can just add it into your Maven thing, into your POM XMLs or whatever, and it's compatible with many different languages. And you can just, there you go. Now you have a professional-looking reporting framework that you can just start using and host on wherever, and you can let people who aren't tech-savvy people go and check test reports and try to reproduce bugs manually. And you can, of course, customize this if you don't like the way it looks. It's all open source. The documentation is a little bit lacking, but if you just go into the source code and read a little bit, you can reverse engineer just anything. So, but of course, the end goal is continuous integration. You want thing to test continuously each time someone else makes a deploy, and you want to be able to track down bugs when they happen. So let's say that you have people working on 2 branches, and you're testing a web page with Selenium, and this web page is running on one server. So every time they deploy, every time they make a change, it gets deployed to that server, and if you're in the middle of a test run at that time, well, your entire test result is wasted, and you have to start all over again. So what we did to solve this problem is we made the Docker images. Here you can see the problem in terms of a branch. So let's say you have one refactor branch, you have another feature branch, and you have developed getting hotfixes applied to it. And then somewhere along there, you had the horrible bug appear, and if you're just testing the end result, you don't know where the bug appeared. So what you want to be able to do is you want to be able to pinpoint exactly the commit, exactly the version that the bug appeared. And for that, we use Docker. So that and what is Docker? You can create you can create images of the app. Let's say it's a web page that you can host on a server locally on your machine or whatever, and then you can test each version in isolation. And you can get this to run in the cloud. You can run it on your build agent. You can run it on a machine, remotely controlled. So it really isn't. All you need to do is you need to get your local developer team to set up a Docker to produce Docker images each time they make a commit, which is that's might be a big ask, but usually isn't. So, of course, in the end, I have a live test of a test. So let's see if this works. And you can see here, it's not a whole lot of code to get started. I just wrote this, in a couple of minutes. And hopefully this will actually work when I run it. And there you can see it's opening Google. It's typing in Knowit. It's going to Knowit the first result. Oh, it's opening is it clicking on careers? Is it maybe searching for test jobs? Is it might perhaps be looking for test developer? Is that you? Well, maybe it is, and maybe you can fill in my information here, and there we are. This is an example of what is possible. So, encourage everyone to get started. That's it. Any questions? Do you want a block? You have to speak into it if you want people to hear you.
If you can keep the screen there. If you the code that is below the Chrome driver, or if you have Firefox driver, is that the same, independent of what kind of driver you use?
You can use everything inherits something called a remote WebDriver, which is used to run on remotely, but you can also run it locally.
So if you make some kind of C# script that, like you do that, load a page and populate an element and submit, that kind of code, you can reuse it for different web drivers.
Yeah, you can use it for.
It's the same syntax.
Yes, we wrote in our Java project. We had support for just specifying in an XML which sort of browser we wanted to run, and the same code was used to run Firefox, Chrome, Internet Explorer, whatever. But the way that happened is that, of course, browsers don't handle exactly the same, right? So sometimes it's not the application's fault that it can't click on something, right?
Yeah.
And so sometimes you need a different hack you remember, right? When, let's say there's an element, right, that you can't click on, or Selenium tells you you can't click on it because it's invisible, and you need to hover over first, right?
Yeah.
Different browsers require different hacks to work around that kind of scenario. But you can just make a check like, hey, am I running Chrome? Then it will just click. Or am I running Firefox? Then it will hover over and then click. And you can make workarounds like that. So, and then you can...
Yeah. Just one small question more. Is there any website architecture scenario that you don't recommend using Selenium when Selenium is not easy? I mean, Angular or some other kind of...
I don't know. I think it's well, the most important thing is that you can find elements in a logical and reasonable way. So one problem is that people, when developers make a new thing, right, and they don't attach IDs to different elements, it can be hard to find the correct thing to click because you are, as you can see, maybe, if I can blow up the code, perhaps, you can see that the way I'm finding things is by CSS selectors.
Yeah.
Right? And if there's an ID attached, it's very easy. You can just type in the ID of that element and click on it or do whatever. But if there's no ID on a specific element, you have to do stuff like that, where how do you recognize an element? Oh, it has a class search box. But beyond that, I don't think that there's any framework that can really mess it up.
Okay, thanks.
Yep, just give him the box.
Yeah. I've done some automated testing myself, and I'm coming from a Cypress background.
Yep.
I'm not going to start the Selenium Cypress turf war here, because we'll have plenty of time for that tonight. But what I wanted to ask you about is, one of the features that I like most about Cypress is that you can inject your own mock data from an API, for instance. Is there any way to do that here, outside of like messing with your host's files and setting up your own server?
I suppose you can write wrapper functions, which will do whatever you need, and just use those wrapper functions.
Yeah. Do you have any experience with that?
Not really. We just tested against the real deal, so we didn't need to mock anything. There's also a possibility of, on the developer side, just detect if you're being automated and then inject.
Yeah, so you have to modify your own code, like not the test code, but the actual code?
In that case, you might have to do that. Or if you are, let's say you are writing Selenium in JavaScript, then it makes sense to have the UI test as part of the actual repository, which is also probably written in like the application. And then it makes more sense, or it's more clear when you can do stuff like that.
Yeah, cool. And for those of you interested in Cypress, come and see my talk tomorrow.
I will be at your talk tomorrow.
Yeah, but what I will say immediately is that this can automate a lot of more like platforms and browsers. So it's a really powerful tool. There's no need for a turf war. It was a joke. Okay. Anyone else?
Here's an example just of a simple wrapper to do whatever. So you can just click on an element, which is the native, you can see WebDriver. It gets an element, right? And it finds it, and then you click on it. But maybe I want to wait a second, right? Or maybe I want to do some other checks, or maybe I want to fake something or run some JavaScript first, right? And you can just structure your program like that. And then every time you click or do whatever, it will do these routine steps for you. Like here, it's just a hard wait, but it shouldn't be like that. There are built-in ways of doing smart waiting. So you can wait for an element to appear, you can wait for something to disappear, and there are various conditions that you can set. And usually that's what you want. So if you can wait for an element to appear and then click it, that's how you should structure your abstract functions like click or simplified.
Selenium recently released a headless WebDriver. Have you had any experience using that?
The headless WebDriver?
Mm-hmm.
Yes, we used it for, I'm not sure if I can talk about it, but basically you can use it for grabbing a lot of information on the internet, right?
Mm-hmm.
And that's a very fast way of doing that. There's some problems sometimes with, because a headless driver isn't always, it doesn't come with all the different plugins, doesn't come with all this and that, a lot of features. Let's say you're playing music, right? Or playing a video. That can be problematic if you don't have, I don't know, a Flash plugin or stuff like that. That's usually the only problems that I encountered with using headless clients. But you can, in principle, run all these tests headless. You don't need to see them, and then they will run maybe a little bit faster. But yep. Okay.